Alright, section 7.5, graphing linear inequalities, okay? The important thing to remember about graphing linear inequalities is that it's just like graphing linear equations, except for one part, shading, okay? And obviously we'll talk about that in a minute, but keep that in mind as we go through this. Before we did things like, you were given something like x is greater than -1, so that was an inequality, and the way you handled that is you put it on the number line, you found -1, you decided if it was an open or a closed hole, this would be an open hole, and then you shaded in whichever direction. So if it was x greater than -1, then you would have shaded to the right, right? And that would have been the graph of x greater than -1. Now we've got two variables, so we're going to consider what happens in the xy plane. Alright, so that's what we'll consider now. And the way that these graphs will look, and this isn't exactly, I guess, will look something like this. There'll be a line, and it's possible that instead of open or closed holes, we might actually have solid or dashed lines. So it would be a dashed line, and then we would shade a particular side. So we might shade this side of the line. So that's how how inequalities in one variable are related to inequalities in two variables. Okay, so let's actually do some examples, or let me give you the steps and then we'll do some examples of these. Okay, steps for graphing linear inequalities. First, put in slope-intercept form. Second, graph the boundary line. So for step 1, if it's not in slope-intercept form, put it in slope-intercept form. Graph the boundary line. That just means pretend that this thing has an equal sign. It doesn't have a less than or equal sign. Less than or equal to, or greater than or equal to. Pretend it just has an equal sign. Is it dashed or solid? So we will have dashed lines whenever I have, so I'll have dashed lines when, there's a better way to do this. So we're going to have a dashed line whenever I have greater than or, whenever I have less than or greater than. I will have a solid line whenever I have less than or equal to or greater than or equal to. Okay, so I'm looking to the less than, greater than, dashed, less than or equal to, greater than or equal to, solid. Then I got to pick a point on one side of the line. You can call it a test point. If the test point fails, in other words, it creates an untrue inequality, I shade the opposite side of the line. If it worked, I shade that side of the line. And this will all become clear, I think, as we do a couple examples. So copy this page down, pause the video if you need to, and then we're going to kick into some examples here. Okay. All right, here we go. Graph the inequality y is greater than 3x plus 1. All right, well, my first thing said put it in slope-intercept form. It is. Okay. Next thing said, if I remember right, treat it like it was an equal sign and graph it just like you would if it was in slope-intercept form. So this means that my y-intercept would be 1. And then my slope is 3. Well, that means I'm going to go up 1, 2, 3, and over 1. Slope of 3 over 1, and connect the dots. Now, the question is this a dashed or a solid line? We said if it's less than, it's a dashed line. So my dashed line through those points. It still has those arrowheads on the end. Now, this is really the new part. Pick a point to either side of the line. I'm going to pick a point that is kind of, I call it an easy point. I'm going to pick this point right here. I'm going to pick 0, 0. So I'm actually choosing this point, the origin. Notice that it is to the right of the line. Okay. Now, so my test point was 0, 0. So I'm going to plug it in to my inequality. 0 is greater than 3 times 0 plus 1. In other words, is 0 greater than 1? That's what I want to know. 0 is not greater than 1. So we would say that this fails. That means that not only does 0, 0 fail, but every point to the right-hand side of the line makes an untrue inequality. So since it fails, we're going to shade the other side of the line, the left-hand side. So just to reiterate, I chose a point on the left, I chose a point on the right-hand side. It did not make a true inequality. I have to shade the other side. If it had made a true inequality, then I would shade to the right, to that side, okay? That one might be one that you want to watch again. All right, let's do another one. All right, graph this inequality. Now, my first step is put in slope-intercept form. This is not in slope-intercept form. I better do that first. So this is 6y is less than negative 12 minus 2x. Okay? Divide everything by... Actually, you know what? Can we make this less than or equal to? I think that would be good to do an example of less than or equal to. All right? Divide both sides by 6. And I think I get y is less than or equal to, let's see, negative 12 divided by 6 is negative 2. And negative 2 over 6, I think, is going to reduce to negative 1/3 x. Okay? Or in other words, if this was proper slope-intercept form, I'd say, hey, this is negative 1/3 x minus 2. Either way is okay. Now, this means that I've got a y-intercept at negative 2. And then I've got a slope of negative 1/3. That means I'm going to go down 1 and right 3. Okay, down 1, right 3. Slope of negative 1/3. Okay. Is it solid or dashed? Well, it's less than or equal to. That must mean that it's a solid line. Okay. Now, I'm going to pick a point. I can pick any point that I want. Just because I know how this problem... Usually I pick 0, 0. Usually the point that I choose is 0, 0. But because I kind of know where this problem is going, I'm going to pick a different point. I'm going to pick 0, negative 3. Okay, so I'm going to test 0, negative 3. Okay, and see if it works. In other words, when I say see if it works, I'm going to plug it in. So negative 3 is less than or equal to negative 1/3 times 0 minus 2. Is negative 3 less than or equal to negative 2? That's the question that you ask yourself. The answer is yes. So the point that I chose worked. I chose this point right here. It worked. It was good. That means that since the point worked, every point to this side of the line also will work. So these are all solutions to the inequalities. The reason I didn't pick 0, 0 is that I knew it would fail. We just did an example where the point failed. But so that's why I picked 0, negative 3. But really, anytime you can, I think 0, 0 is the easiest point to choose or to use. Okay. All right. Let's look at one more example here. What if I had y is less than negative 3? I'm graphing it in two variables. So on the coordinate plane, y is less or is greater than negative 3. Well, I'm going to start off, I'm going to treat it just like I would a line. So suppose I had y equals negative 3. Well, that would mean I would go down the y-axis to negative 3, and I'd put a point. And this is for all values of x, y is negative 3. So this is going to be this line here, and it's dashed because I've got just greater than, right? I've just got a greater than symbol, not greater than or equal to. So next thing I do is pick a point. Well, let's pick, I don't know, let's pick this point right here, 0, 0. Okay, so choose 0, 0. That's my test point. So I'm going to test 0, 0. And this will be pretty handy because all I have to do is say, well, is 0 greater than negative 3? Is that true? Yes. Because that is true, that means every point above the line will also work. Okay, and that's how I would graph that. Now, I know what you're kind of thinking. You're going, well, Mr. Kressel, what if it's x is greater than negative 3? Well, that would be a similar situation. It would just be a vertical line then. If it was x less than or greater than some value, it would be a vertical line. We would go about it the exact same way. Okay? And that's it for graphing linear inequalities.